So I'm going to type in, let's say, x to the fourth, then minus 13x squared plus 36. Okay, so let's zoom in, check it out. So over here, I got -2, -3, 2, and 0. So this graph crosses 4 times, and all 4 roots are integers. So that kind of makes it easy for me on this one. So again, -3, -2, +2, +3. So let's just write those out. So I'm going to say on Desmos, the roots are -3, -2, 2, and 3. All right, so that makes my job easy on this one. Okay, I don't have to like work in syntactic division or anything like that. So I'm simply just going to write out the factors from that. So x plus 3, because it's minus, and then plus 2, and then x minus 2, and then x minus 3. So now we've got all the factors. So I'm just going to write f of x equals here. All right, so that's pretty much all the factors. So if you can use Desmos to find those factors, great. Okay, but that's easy if they're integers. But when they're not integers, that's when we have an issue. Okay, so that was kind of just an easy toss-up there. All right, so now let's look at, let's do this one. Okay, so now let's say I've got x to the fourth minus 4x squared plus 3 set equals 0. Okay. Again, the only reason I'm setting equals 0 so that because we're looking for those roots. All right. Now, before I move forward on this one, how many possible roots can I have? How many total roots? I got 4. Where are you looking to find that out? On the exponent, right? So the exponent is going to tell us that we've got 4 possible roots. All right, so as I'm looking through this, I want to make sure I've got all 4, if there are 4. Now, that doesn't mean that all 4 are going to be whole numbers. Okay, so it might be decimals or fractions or complex numbers. Okay. Okay, so now I'm going to go to the graph. So now let's do x to the fourth minus 4x squared. And then let's go plus 3. All right, let's see what we got. Flip that off. Okay, so here I've got -1 and +1. Okay, so that works. I've got 2 roots. But then I've got over here these other 2 roots, which are not whole numbers. Okay, and you can see that there's some kind of decimal value. So what we're going to do, because we want the exact values, okay, is I'm going to take one of those factors. So on Desmos, there is -1 and +1. So to figure out the rest of them, okay, or if you figure out the exact values, okay, we're going to use that in synthetic division. So I'm just going to use synthetic division on this first set to factor it out. Use synthetic division to factor. Okay, so I'm going to take that one of those roots that I found and set it up. Now my first number is going to be 1. What's the second number? No, remember I'm getting it from here and it comes from the coefficients, the numbers in front. It's not -4 either. Because if I start with 4 as my exponent, what should be the next term? It should be 3, but it's missing. We got a missing term. Right, so now I'm going to put 0 because we got one that's missing there. Okay, then -4. What comes after that? 3. Not 3 either, because what should come after x squared? x. So there's another missing term. So remember, we got to remember to account for those missing terms. And then the last one, 3. Okay. So again, here, you got to make sure you count for missing terms. Missing terms. Okay. All right, so first step, bring down the 1, bring down the first coefficient, then multiply -1 times 1, and then we add the column. So 0 plus -1, and then you just keep repeating. -1 times -1, +1. Okay, then add. -4 plus 1, 3. Then multiply again. -1 times -3, +3. Then add again. 0 plus 3, 3. Then multiply again. -1 times 3, -3. And we should expect to get a 0 because we already know it's a factor, but we're just trying to use that factor to factor out the rest. Okay, so from that, now my new equation is this. I have already know that x minus, or that -1 is a root. So what's the factor for a -1?
1.
X what?
Plus 1.
+1. And now what's the degree, or what's the exponent of the first term I write? It's not 4. If that's 4, the first one is 3. And we always go 1 down from what you started with. Okay, when you write out the factors. So remember, I'm using this coefficient right here. The numbers that, all these numbers I came up with on the bottom, that's your quotient, that's your answer, right? Okay. And those are the coefficients for these terms. So the first one is x cubed. Next one is what? Minus x squared. Then minus 3x, because I'm just using these numbers here. Then plus 3. And that's the last part there. Okay. Okay, but we want to keep factoring out this equation. Okay. So we already have one factor. Now we're going to use the other one. We already know another number. Okay. The 1, positive 1, is also a factor. So then we're going to do it again. So now I'm going to set up this synthetic division one more time. But now when I set this up, I'm going to use these terms. Okay, because we're trying to factor this part, not the original. We're just factoring this part. Okay. So now I bring the coefficients down from that. So now 1 minus 1. And notice there's no missing terms this time. Okay, we have cubed, squared, x, and 3. Okay, then minus 3 and 3. Okay, so I bring down the 1. And now I've got to multiply, just like before. 1 times 1, 1. Add, that's 0. 1 times 0, that's going to be 0. Then add, it's -3. Then 1 times minus 3 is -3, which again, we should expect 0, which is your remainder. Okay, so there's the new terms that you're going to write out. So first, I'm going to write the x plus 1. That was from the last time we did synthetic division, the first time we plugged in the root. Then I know that positive 1 is a factor, so I write x what? Minus 1 this time. And then I'm going to write the rest of the terms here. Okay, so the first term, the coefficient's 1. What's the degree or the exponent of that first term this time?
X squared.
X squared, because right, I started with cubed this time. So that means my first term will be squared. And basically, it'll just keep going down if you keep working through this. Okay, but then I have 0, right? So I don't have an x. It's just going to be blank. And then it's going to be minus 3. Okay. Now, that is not a factor. Like 3 is not a factor. Because you think about it, when we went to the graph, This doesn't even cross at positive 3. Okay. So what we're going to do is we're going to take the x squared minus 3 and solve that to find those last factors, okay, or those last roots. Now, if you guys watch the video, you can, Ms. Menard talks about using the quadratic formula, okay, for this one, because I can't set up the x for that. Okay, there's an easier way when it's just these two numbers. When it's just x squared minus another number, or even plus another number. It's a much easier way. What I'm going to do is take this and set it equal to 0. Now, if you have 3 terms, if it's like x squared, an x term, and then a constant, you have to do the quadratic formula. But if it's just these two, I'm going to take these, set it equal to 0, and solve for x. Sorry, it's x squared minus 3. So what do you think the first step is here? All right, add 3 both sides. X squared equals 3. What's this last step there? Square root. So x equals the square root of 3. Now, when you square root a number, you got to remember, what do we have to remember? When we're solving and we square root a number, we get 2 solutions. So what do I need to write? Right, plus minus. Okay, so I have 2 solutions that are coming from that. Okay, so there's my exact value. Okay, we saw that on the graph is like 1.7, so that is equal to 1.7, blah, 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 you know, if I keep going. All right, so now the question obviously was, what are all the roots? Okay, the roots are minus 1, 1, positive square root of 3, and negative square root of 3. So now we know all the roots. So I'm basically using synthetic division to factor out this whole thing. Now, there will be, again, though, some cases where that will not be just 2 numbers. It won't be just x squared and another number. It'll be 3 terms. In that case, now you're going to need the quadratic formula, okay? So that is pretty much what's going on with this first. Let me go to the second packet here. Where's the, pause here for a second. I forgot to add that to the recording, but I was just saying you guys have to use the quadratic formula here. And the graph, this question was, how does the graph help? It helps us see the double root so that we know that we have to use synthetic division twice. Okay, so once you use synthetic division here, you're going to write all the coefficients just like we did in our notes here, like this. Okay, and then you're going to use quadratic formula to figure out the last 2 roots. Okay, now on the back page, okay, it wants to sketch that polynomial out. So on this one, you guys just use Desmos for this one. And the main things that you want to show on your graphs is x-intercepts. What else is an important point to have on there? If it has one. Well, it should have one. What's another point that we want to make sure we include on those graphs? Y-intercepts, right? So those are probably some critical points that you guys can put on there. Okay, and remember, it's a sketch. Okay, so it doesn't have to be perfect. Just get those critical points down, the x-intercepts, y-intercepts, and then kind of sketch it on there, okay? Okay, so then this one down here, Spud has done it again. He has lost another polynomial function. One is cubic. This one is cubic, written in standard form. He knows there were 2 complex zeros, -2 plus 5, plus and minus 5i, and 1 real 0 at -1. What could his original function have been? So first of all, bless you, it says cubic. So what's the highest exponent? 3. right? And then it's written, they want us to write in standard form. So we have the roots. So now we just have to work backwards, okay? So let's write out the factors. So first, I'm gonna write y equals, I'm gonna start with the easier one, the real number. So if it's -1, my first factor would be what? X plus 1. Okay, now we have two complex roots. Okay, do you guys remember how to write those out? Still going to start with x, but what do I write after this?
Equal.
Not equals. I can put equals in there. Because the next root is this, -2 plus 5i. How do I write that in there? Yeah, you just write it in there. So it would basically just be -2 plus 5i. And then over here, again, -2, but then just write minus 5i. Okay. Okay, now your job is to multiply it out. Okay. So you'll want to do this one thing at a time. Now notice these are three different terms, right? So three different terms means what kind of box? A 3 by 3. So you can kind of start this however you want. You could start by multiplying this and do a 3 by 3. Or if you do these two first, then it would be a 2 by 3. Okay, so first you're going to want to multiply these out with a 3 by 3 box. And you should end up with, you'll probably end up with like 3 or 4 terms, because some of these are going to cancel out. A bunch of them will cancel out. I don't know if you guys remember doing a problem like this before. After that, then you're going to have to multiply the x plus 1. Okay, so that will be the next step, times whatever your expression is from that. Okay. Okay, so let's see. Because at first I thought it was asking you to plug it in. So what this is asking you to do is basically try 2 as a number to divide into this polynomial. So what you're going to end up dividing is you're going to take this polynomial and then divide by x minus 2. Okay, so divide by x minus 2. So when you set up your synthetic division with 2, and then divide that polynomial, so -6. And the reason you do this is basically, instead of plugging it into the function, like, like when I asked you, okay, plug in the input of 2 and then figure out what the output is. This is another way of doing that. This allows you actually to do the same thing using synthetic division. So it's like you're basically trying to figure out what the y value is using synthetic division. And so you set it up the exact same way. And so your remainder is the output. Okay, so your remainder is the output of that. Okay, so that's what you're looking for, is the remainder. Okay, after you plug in that too. Okay, so this one, you're going to use the factor theorem to determine a factor of that. Okay, let's see. Hang on a second. But that's pretty much what you're getting from there. Determine just one. Okay. I feel like that's the exact same question. You know, guys, just cross that one out because literally that's like the exact same question. Because this is basically just saying to find a factor, and you're going to end up doing the exact same thing you did here, and you're going to do it there. So let's see, use your answer to determine another thing, factor. Okay, so here's what you'll do. Okay, so we already know, like based on this question, you're going to find a factor. Okay, so I want you guys to use this to find another factor. So you're going to have f of x equals x minus 2. And then you're going to have this answer will go here. And then from that, find the factors. Okay. And you'll end up with the x squared term, right? So this is going to be something you're going to be able to factor. Okay. So basically just take your answer from here, plug it in there, and then factor this out. Or find the roots from that one. And then this will be just what are the roots. Okay. And then on this, just list all roots from that. Okay. So you'll factor this out. Okay, then take this, plug that in there, and then factor this last part out. Okay. All right, I'm gonna stop there because I want to make sure I give you guys a little bit of time here to work at the end. You guys at home, I will see y'all tomorrow. And that's it. All right, have a good day.